called data structure, we're going to study on list and string. Now, you have learned list and string before. We basically introduce it informally as a way to store some numbers or some alphabets or some characters when it comes to string. And list, we store numbers, store the floating point numbers, and so on. So this is what we use when we want to write programs, okay? But today we're going to study more in depth into this data structure. So I often mention the word data structure. So what does it really mean? So these are the structure of data that you want to store. So when you write a program, you often have certain data. Okay, either it's binary number, or it's some string, or some character, some text, or some music. These are all data. And how you want to manipulate, how you want to store this data is defined by us as a developer and programmer. Now, there are already existing data structure, such as lists and strings, because these are common. And so it's being introduced or created by a programmer that creates these data structures. So it supports certain things that we can do with this thing. So let's start with list. We say the list is a data structure that handling a list of things. What are these things? It can be any objects, okay? It can be integers, or it doesn't have to be all integers. Some of them can be floats, some of them can be integers. And it can be not just integers. The list itself can also contain string, for example, okay? So let's just have a quick demo. So here, for example, is a list of integers. I can also create another list that contains a floating point numbers, or I can also create a list with some string, or another list, empty list. And that is perfectly fine. It was defined or created in such a way that it can contain many different types. It's just used as a container to store these objects, okay? Now, what is the things that we want to manipulate? Why do we store them? Because we want to use them. What can we use them for? For example, we use them to retrieve something. So we want to know the first value. What is this? So how do we have a way to extract this element inside this list? And that is using the square brackets, okay? So how do we do that? We have learned it using index. So we come to that later on. Now, another term that I want to introduce is called mutable. List elements can be changed, okay? So when we create this data structure, we say that we not just want to retrieve or use it as a storage, we also want to be able to change it, all right? We want to be able to update individual value. We want to go through individual value, check it if it's certain condition that we satisfy, and then we manipulate them. We want to, for example, delete some of the values. We want to add some of the values inside. So these are the things that is created as a way to manipulate this kind of data structure. And this is what we're going to learn. So first, start with index. How do we retrieve an element? How do we identify which element that we want to retrieve? Okay, so this we have learned before. So to get an element, we need to know which position it is lying in its container here. Okay, so we learned that it's using index. Now index can start from 0. Okay, so we have seen before, index start from 0. All right, from the left, we start from 0, and then the next value index is 1, subsequent value index is 2. All right, so this gives us a position of where this data is. So say if I want to look at the data, the first data, I look at index 0. If I want to look at the second data in my list, I look at index 1. So we have seen, for example, if L equals to 0, 1, 2, L0 will return the value at index 0. So index 0 will be the leftmost, that will be 0. And how about L square bracket 1? It will return the second element because we start counting from 0. So starting from left to right, so this will return 1. And L2 will return 2. Okay, so we start counting from 0. All right, so if I change this now, for example, to 2, 3, 4. So tell me what is L square bracket 0? 2, good. And this? 3 and 4. So what is L3 then? There will be an error. Okay, there will be an error. There is no such index. It contains only 3 elements, so the index will be 0, 1, 2. There will be no index 3. Now, we can also count from the back, as in from the right to left. If we count from the right to left, we start with -1. Okay? -1, -2, -3. Okay? So L square bracket -1 means we are looking at the last element. So it will return 4. And L -2, again, so this is -1, this will be -2, this will be 3. And L -3 will be -1, -2, -3. That will be return 2. Okay, so we have a flexibility of how do we want to define the index. So either from left to right or counting from right to left. Okay, so here we have seen an example. So for example, here I have L -1 is equals to 4. Now, what is the rationale to do that? Because sometimes we want to know what is the last element. And I don't want to start counting from 0 from the front to know where is the last index. So basically, if I want to know the last index, counting from 0, okay, that will be length of L -1. That will be the last index for the last element. Okay, it will be 4. Okay, so length L -1 is the last index if counting from left to right. Right, but you know that will require the computer to compute what is the length of L first, and then -1, and to start counting from 0. So there is a shortcut where you just do L -1, and you automatically retrieve the last element here. Okay, good. Now we also have learned how to retrieve the size and etc. etc. But now I want to know, for example, here, if I have a quiz that stores the score for each quiz here, and I want to retrieve the number of elements in quiz or the number of quizzes. So we have learned how to use length of quiz. That will be, first I need to run it first, the number of elements in quiz. So there will be 11 quizzes. Okay, now if I want to retrieve the score for quiz 1, so assuming the first quiz is quiz 0, so I will just do quiz square bracket 1. So this is how we use the list as a use case. All right, so if I want to keep track of the quiz that I have, if I'm one of the students and I have all the quiz coming to me, and every time I just store it inside this list here. So if I want to retrieve it, I don't have to count myself 0, 1, 2. If I want to say, I want to know quiz 5, so I just do quiz 5, and that will give me, without having me to count one by one or look through my papers to see what is the quiz. So I store everything into this list, and then I figured out what is, I can manipulate this quiz number here. This quiz, retrieve the number of quiz that we have so far, and of course, the particular value of a quiz for a certain quiz. Okay. Now, before I go to updating, I want to talk about slicing. Okay, so let's talk about slicing here. So a long time back before, I talked about when we want to ask user for their name, first name and last name, and then you take the first 2 characters of the first name, first 2 characters of the last name to form the initial. And I mentioned that if the user first name is actually just containing 1 character, then you have a problems of extracting the second elements in that first name. And I say one of the way to go around this is to use if and else, and another way is to use slicings. And this is what we're going to learn today. So what does it slice? Is to slice is basically used to extract elements in the list. Basically, we want to create a sublist. Okay, extract a subpart of the list. Okay, so what does it mean? So if you have learned range before, okay, let's start with slice. Okay, so let's start with a little recap on range. Okay, so we have seen that range takes some start value, some stop value, and this will generate integers from start. Okay, and then the next one is start plus 1, start plus 2, and so on until stop minus 1. It doesn't stop at stop. So you will stop at the value of stop, but not including stop. So the last value will be stop minus 1. So this is how we create this function, how this function was created, using a range with a start and stop. All right. Now, so start, for example, can be 0, and range, for example, can be 10. So what it generates, we need to typecast it into list to see what it generates. Will be generate integers from 0 to 9. Now slicing is also almost the same thing. It also has start, stop, and it also have a step. So we will just ignore the step for now. Okay, so step is equals to 1 by default. All right, so you are also asked to give two numbers, and these two numbers are inside the square bracket. Okay, and it's not separated by a comma, but it's separated by a colon. Okay, so again, just like range, if start is not provided, the default value is 0. If stop is not provided, default is the length of the list. All right, and you can omit the numbers and leave just columns, for example. If the numbers are being omitted, it will take the default value. If, for example, we'll see an example later. So let's start with this one here. So this is my list 0, 1, 2, 3, and I put the index on top. All right, we start counting from 0, from left to right. Now, what does L01 means? It means that it's going to start taking the element at index 0 all the way, but not include index 1. Just like range and stop. Okay, it start from 0 all the way, but not include 10. It's the same idea here. You start taking the element at index 0 all the way, but not include index 1. So you start taking index 0, and then you see 1, you stop. Index 1, you don't take it, you stop already. So you return just the first element in the list. Okay, so else square bracket 0 colon 1 here returns a substring that contains only the first element. Now let's extend it, say this is my start value and this is my stop value. So what it does is that it's going to start extracting element starting from index 0 all the way, but not including index 2. So it will type 0 into my list, into my sublist. It will take 1 into my sublist, and it's look at index 2. This is where it stopped taking. So this will be my final list that being returned. Okay, the same thing here, L03, it will start taking elements into the sublist. All right, starting from 0 all the way, but not include 3. So it will start taking 0, 1, 2, not include the element at index 3. So we have 0, 1, 2 here. Now what is L04? Now it's the same. It will start taking every element starting from 0, index 0, all the way, but not include index 4. So it will take those that are in index 0, 1, 2, 3, basically the whole thing. Okay, so let's look at this again. L equals to 0, 1, 2, 3. Okay, now by default, if you don't provide the if you don't provide the start value, it will start from 0. So in particular, if I just do this, L colon 4, so it will start taking elements from index 0s all the way, but not include index 4. That will give you just the whole list itself. Okay, now, so the default value start is by default equals to 0. Okay, now the same thing, say I want to take starting from 1 all the way to the end, and I don't need to specify the end value. Okay, so end is by default equal to the length of L. Okay, what does it mean is that you start taking from taking elements at index 1 all the way towards the end, and you don't have to specify it because by default it will be towards the end. So what you take is you take starting from index 1 all the way towards the end. Okay, and now if I omit both value, okay, if I just do this, okay, so then start is by default equal to 0, and end is by default equal to length of L. So what does it mean is that it will start taking elements starting from index 0 all the way to at the end. So it would just take the whole list itself. Okay, so what you have here is that this L column without any starting and ending value is essentially creating a duplicated copy of L. So basically creating a duplicated copy of L. Okay, so that is called slicing. All right. Now, what we have seen that the square bracket, we can use it to get the value at a particular index. If you supply just one element, say L square bracket I, it will just retrieve the I index of the element. And then we can also use it to get a duplicated copy of the string using slicing without supplying the start and end. That means it will take every element starting from the 0 index all the way to the end. So you basically create a duplicated copy. And you can get a substring of string using a substring of list, okay, using slicing. So we just, for example, interested in the first few elements. Okay, say here, I have, this is my quiz score. Suppose this is my quiz score. Okay, and if I'm only interested, suppose I am only interested in the quiz score of the second half of all quizzes. Okay, and we know that there are how many of them? Say 11 quizzes. I'm going to make it 12. Say there are 12 quizzes. I'm only interested in the quiz score of the second half, or say of the first half. Okay, let's just make it easier. For the first half of all the quizzes. So I'm only interested in the first 6 quizzes. Okay, so in other words, suppose there are 12 quizzes and I only interested in the first 6 quizzes. Okay, so I don't need to store the rest of the 6 of them. I just need to store the first one, or I just need to take some the first 6 quizzes. Okay, for my manipulations. Okay, so how do I do it? I use slicing, for example. So I'm interested with the first 6. So starting from 0, I can omit it. Okay, until what? You want to first 6 means from quiz 0 to quiz 5. Okay, quiz 0 to quiz 5, inclusive of quiz 5. So we start counting from 0. So 0, 1, 2, 3, 4, 5 will be 6 quizzes. So the last quiz is quiz 5. So my end index will be 6. Okay, this will give me the first 6 quizzes. So 1, 2, quiz 0, quiz 1, quiz 2, quiz 3, quiz 4, quiz 5, and all together they have 6 of them. Okay, so first half quiz. So first half quizzes is equals to this. And you can, for example, print it. Say first half quiz. And this will be 6 of them. And you can even verify that it has 6 of them by executing the length of this. Okay, so you can even omit the 0 because by default it starts with 0. All right, then you get the same answer. So this is how you want to use slicing. We often use it to separate the 2 lists, for example. And now, let me just ask you, if I'm only interested in the last 6 quizzes, so I'm on not just the first part, I'm only also interested in the last 6 quizzes. That will be from quiz 6 to quiz 11. Okay, 6, 7, 8, 9, 10, 11. So 6 of them, the last 6 of them. So how do I do this? Okay, so I will have, this is my second half quiz. Okay, so you, for example, you want to compare before the midterm, how do you do it? How do you do better than the second half? So you want to separate them. So second half quiz, now we start from quiz 6, okay, all the way towards the end. Now I can, for example, put 12 here, but I'm lazy to count, so I'm just going to leave it there. I know it's starting from 6 all the way to the end. By default, this will be the end. All right, so I'm going to run this, and I'm going to print it out if I want. example, second half quiz. All right, and this is my second half, the list of scores of the second half of the quiz. Okay, now I can also verify that it contains 6 of them. Second half quiz, there are 6 of them. All right, now for example, if I want to make a comparison between how I did in the first half and how I did the second half, I can take a sum of the first half quiz. For example, say I generally do better over 6 of them, so I take the average half quiz. All right, so this is the average first half quiz score. So on average, for the first half quiz score, I take the sum, I divide it by 6 because there are 6 in the first half. All right, and this is my average in the first half quiz score. Okay, I can print it. Okay, same thing. How about my second half quiz score? Okay, then instead of first half, now it's my second half. All right, and let's see. Say, let's see. Okay, suppose I didn't make a mistake here. So it turns out that my first half has average score 4.08 and my second half also have an average of 4.08. Means I do the same in the first half or the second half. Okay, so this is also interesting. So next time when you have all your quiz score, you can figure out whether you do better in the first half or the second half. So this is something that you can play with whatever they have learned today. So you have learned how to take the first half, how to take the first half here and how to take the second half here. Okay, now what are the things that you can do? For example, reverse a copy of the string. Okay, so this is something extra that I won't show here. So it has something to do with the step here that I omitted here. Okay, step basically by default is 1, but if you want it to be reversing, you can take step equals to -1. So to get the reverse copy of the string, okay, what you can do is that you do L with a square bracket as well. Okay, so start from 0, end with the last element, which is length of L, and instead of 0, so this will give you a copy, right? So this will give you a copy. This will give you a copy, but if you want it to be reversed, you have another column with a -1. This will give you a reverse. Okay, so what does this step here do is that, for example, I didn't want to go into details because we're not going to use it in this course, but it's kind of just saying that starting from 0, the next one that you take element is not equal to 0 plus 1, but 0 plus step. Okay, that's the meaning of step. So previously, without this second column here, the value of the second column step is equal to 1. So when you take the next element, it will be 0 plus the previous element. All right, but now the index that you are considering is no longer 0 plus 1. 1 is not the next index that you are looking for, but it will be 0 plus 2. It will be the 2 index 2 that you're looking for. That's the step. It could basically help you to decide which index elements that you want to take. So for example, let's look at this example here. We have L042, which means you start taking element at index 4 and all the way until, but not including index 4. But the subsequent elements that you take, always it will be +2. So you start counting from index 0. So you take index 0, okay? And the next element that you take is not 1, but 0 plus 2. So the next element that you take is 2. All right, and then you continue. You're going to take 2. The next element that you take is not 3, but 2 plus 2, which is 4, index 4. But you say that you're going to stop at 4. You're not going to take element at index 4, so you stop taking it. So your final sublist for this part here will be just list of 0, 2. Okay, but in this course, every step that we're going to do is equals to 1 by default. But I just want to explain to you, if you want to do reverse, your step will be -1. So you're going backward, okay? Now, there are a couple of things that we also can do besides all these quiz and so on. Now, I want to teach you these are all the things that we have learned so far, which is to take something from the list or take sub-elements from the list and so on, okay? Now, what I want to do is that one thing that we haven't tried is to change the element or change the value in the list, okay? Suppose I make a mistake in the score, okay? Suppose the score for quiz 1, so let's first retrieve the score of quiz 1, is 4. I make a mistake, okay? The grading is wrong, I make a mistake, it should be 5. All right, so what should I do? I want to change it. So what I can do is that I use the same thing, quiz 1. Now I give it a new value, say it's equals to 5. Okay, so now quiz square bracket 1 means I'm going to go into the index 1 of quiz and set it equals to 5. This is to update the score for quiz to 5. Okay, so let's retrieve it again. So previously it was 4. I set it equals to 5 now using equal sign, and what I get now is 5. Okay, so this is how you do update. So update is very simple. Okay, you just do the same as before. You want to update which index, element at which index, whatever that you want to update, you just equals to the value that you want to update. Okay, so for the example, say I want to update, say quiz 2 is 3.5, and suppose I say everyone in quiz 2 you get 0.5 bonus mark. Okay, so I say okay, so 0.2 now is equals to, okay, let me just do it this one. So suppose quiz 2 everyone get bonus 0.5 more. Okay, so quiz 2 now should be equals to 4, so you should set it equals to 4. Okay, and now you can print quiz 2 now, so you can just retrieve quiz 2, and now it's equals to 4. Okay, but the downside of what I'm doing is that I explicitly say it. Okay, so let's look at the original quiz 2. So I'm gonna run quiz again. Original quiz 2 say is 3.5. If I say everyone should get bonus 0.5, I don't want to look into each one of your quiz and then manually add 0.5 myself. So I don't do manual work when the computer can do it for me. So what I can do is that you take the old value of quiz 2 and then you just do equals to the old value of quiz 2 plus 0.5. Okay, so I don't have to print that out and do manual calculations myself. I ask the computer to do it for me. What is the value of quiz 2? Whatever it is, you add 0.5 and store it into in the index 2 of quiz. Okay, so this is how I do it, and I get this. So without having to manually compute this value myself. Okay, good. So this is how you can change using equal sign. Now here, I mentioned before, you can create a duplicate copy of the list. Now, earlier on, I have mentioned that if I do quiz copy is equals to quiz this. That means you create a sublist starting from 0 all the way to the end. Okay, now let's analyze this. So quiz copy will have the exact same value as quiz. Okay, now if I change now quiz copy to, say, a quiz copy 0 to 0. Okay, so which means it goes to the 0 index of quiz copy. So quiz copy is this one. It goes to 0 index of quiz copy and set it to 0. Okay, so let's now see what happened to my quiz copy. Quiz copy now we have 0 at the first quiz. Okay, and it doesn't change quiz. Okay, quiz remain the same. It's still 5. The only changes made is on quiz copy here. Because what we did here was create a duplicated copy, and we only make changes on the duplicated copy. We didn't make changes on the original quiz. Okay, so what I want to say is that because if I create a quiz fake copy, okay, so I call it fake copy. It's not the right word, but I'm just wanted to put it out. So if I do it quiz fake copy is equals to quiz. Okay, So now if I print quiz fake copy here. Okay, I have the same quiz fake copy has the same value as quiz. Okay, however, quiz fake copy is the same list as quiz. It's different from before. So this is a new string, a new list with exactly the same element as quiz, but here quiz fake copy refer to the same list quiz. Okay, so what's the difference? Because if I change quiz fake copy 0 to 0, okay, and if I print quiz fake copy, all right, the first one becomes 0. And if I print quiz now, the first one is also 0, even though I did not explicitly change the 0 index of quiz to equals to 0. Now the difference is here. When you do quiz copy, fake copy is equals to quiz. Quiz fake copy is not creating a new list. It's referred to the same list here. Okay? So whatever you change is basically changing exactly the same thing. So if you make changes to quiz fake copy, it will make changes to quiz as well. Before this, you create a different list. Okay? So there will be two lists created here. The subsequent list is where you make the change. The first list will not make any changes at all. All right, so that's the difference between the two. So it's very important to understand the difference between the two, whether you are creating a new list or you refer to the same list but given a different name. So we call this, so basically, quiz fake copy is just an alias of quiz. What does it mean? Is that they're both, it's the same object, but it have two different names. It can be as quiz or it can be as quiz fake copy. Okay, it's called an alias. Some terms that you might see in the literature in the future. Basically, you have two different names, but they refer to the same exact object. If you change one of them, you change the other one because they actually refer to the same thing. As opposed to this one where you create two different lists, they're just having the same element. If you change one, it will not change the other. So this is a very important difference between the two. Okay? Now we're going to continue with the rest on other things on lists that we can do. In particular, other functions that we're going to need in order to solve some of the use case. For example, some of you asked me, how do we take the best 10 score out of 12 quizzes? Suppose we will have 12 quizzes, and you know that the best 10 scores contribute to your final score of the quiz. How do we find it? Do I look for it myself, or do I find a way to create an algorithm to solve this? So this is what we're going to learn on Wednesday. Thank you, class.